All right, kiddos, so this is part dos of doing factoring and, oh, geez, sorry. What I want to focus on is how to factor trinomials when the leading coefficient is greater than 1. Again, I apologize for any toddler music you hear in the background, or possibly my kids, because again, I'm sitting at my kitchen table. But I just wanted to, again, kind of go over a few example problems with you, give you the strategies for you to be successful, show you, some, like I said, some examples, the step-by-steps, give you something to go from. Keep using Khan Academy. Keep using your Algebra Nation. Keep using your textbook. You have so many resources. Message me if you have a question or put it on Google Classroom. I'm doing my best to check that to answer you. All right. Wow, there it is. Factoring trinomials with a leading coefficient greater than 1. It's a lot of grouping for this. So our strategies, again, just like we were doing before, you're going to multiply your A and your C. So the form is ax squared plus bx plus c. So first you multiply your A and C. Then you list the factors of whatever AC is equivalent to that product. You pick the factors that when you add them, the sum is equivalent to your B, right? Okay. Now, before you just went ahead and put them in their grouping and like you were just done. Well, now that there's a leading coefficient, we have a little more work. We have to do what's called grouping. So that big step is, let's see if I can fold this page down. There yet. Let's see if I can do this. Sorry. Okay, here we go. You rewrite the equation substituting in the two factors for B. So instead of writing it with your B, you're going to place the two factors that you got in for your BX. Okay? So let's say it was 2 and a 5, or a 3 and a 5. It'd be, whatever ax squared plus 3x plus 5x plus c. We'd get rid of whatever the b was and rewrite it with our two new terms. Then we would group them. Then we'd pull out the GCF, greatest common factor, right? Simplifying each one as much as possible. Then we have our answers. The two numbers, or even sometimes the two terms that we pulled out, become our one factor. And you'll notice once you do the common factoring, what's in each of the parentheses are the exact same. If they're not the same, you did something wrong. But that's your second part, okay? I know right now you're probably like, what? Maybe some of you are like, I got this, Fritchie. But either way, we're going to, there's our strategy. Now we're going to apply it to some examples, all right? So first example here, 3p squared minus 2p subtract 5. Woo, woo. There we go. 3p squared, subtract 2p, subtract 5, okay? 3p squared, subtract 2p, subtract 5. Go ahead and write that down. All right, we wrote this. First thing, I'm going to multiply my first term, my a, by my c, and that is 3 times negative 5. So I'm going to be multiplying my 3 times my negative 5. All right? So 3 times negative 5, and I get negative 15. Negative 15. So I know that the two factors have to be a positive and a negative, but since it's a negative 2, I know that the number that's larger has to be the negative, and the smaller number has to be the positive to get a sum of a negative number. So my factors of negative 15 are positive 1, negative 15, right? Positive 3 and negative 5. Now I get to stop because I know that negative 5 plus positive 3 is negative 2. This is the same stuff we've been doing. Now here's where the difference is. Now we're going to take our two factors, 3 and negative 5, and we're going to substitute them in for this negative 2p. Because really, 3p subtract 5p is negative 2p. So I'm just stating negative 2p in another manner, okay? So how I got the negative 2p was I took 3p and subtracted 5p. All right, so again, I'm substituting the two factors in for my b. So I'm going to rewrite this. Now I have 3p squared plus 3p minus 5p minus 5, or subtract 5. And I'm going to go ahead and point out to you that what I did was, instead of my negative 2p, I substituted in just like this. Everybody see that? And that's equivalent. 3p minus 5p is negative 2p. So I'm just substituting in. All right? Now I'm going to do the next step, which is grouping. I know that 3p squared and 3p have a lot in common, so I'm going to group them. And negative 5p and negative 5 have something in common. So what I did now was called grouping. This is going to make it really easy for me to take out a GCF here, a greatest common factor from each. All right, so I'm going to go ahead and look at my first set of terms, 3p squared plus 3p. Well, what do they both have in common? What's the greatest integer and what's the greatest variable or exponent I can take out? Well, they both can afford a 3p. So if I divide out a 3p from 3p squared and 3p, what I have is p plus 1. Okay, so I divided 3p squared and 3p by 3p, and I get p plus 1. Now I'm going to focus here. Well, what can I divide out from both negative 5p and negative 5? Negative 5. So I'm going to divide by negative 5. All right, so if I divide negative 5p by 5, or negative 5, sorry, and negative 5 by negative 5, what I have left is p plus 1. Okay. So look, what's in both parentheses is p plus 1. If what's in the parentheses is different, you did something wrong. They should always be repeating. So I know one of my factors, or part of my answer, is p plus 1. The other binomial is 3p subtract 5. So whatever my greatest common factors were, that becomes one of my binomials, and the other one is whatever was in the parenthesis. So my answer becomes 3p subtract 5 and p plus 1. And of course, you would want to go ahead and check with double distributing, but that's it. We're going to go through this process again. That way you get more acclimated to it. We're going to see all of our steps, but what we're doing, the big thing that's different is we're doing substitution, grouping, and greatest common factors. Here's our second question. Negative 6a squared, subtract 25a, subtract 25. All right, so negative 6a squared, subtract 25a, subtract 25. Now, if we were in class right now, I'd be like, someone tell me what is our first step, right? Strategy is everything. I cannot reiterate that enough to you. Strategy, strategy, strategy. Because no matter how crazy looking the problems get, you know exactly what to do, right? And we always are going to pay attention to our signs. First, multiply our A by our C, right? Leading coefficient by our constant. Negative 6 times negative 25 is positive 150. All right, so I'm going to write 150 over here in the corner, and it's a positive, right? But when I look at my B, notice it's a negative. So that means to multiply and get a positive, but to add to get a negative, it has to be two negative numbers. So I'm going to list the factors of 150 using negatives. Negative 1, negative 150. Obviously, like, it's not going to be, I know it's not going to be numbers that are too small because there's too great of a distance between them to ever get 25. But, so negative 2 and negative 75, negative 3 and negative 50, not 4, negative 5 and negative 30. So negative 5 and negative 30, that makes negative 40, too far. 6 doesn't go into it, 7 doesn't go into it, 8 no, 6 does. 6 and 25, but that also doesn't make 25. 7 doesn't, 8 doesn't, 9 doesn't, 10. Negative 10 and negative 15. So the two factors I'm going to pick are negative 10 and negative 15 because negative 10 plus negative 15 gives me negative 25. So, again, here's our difference in these types of problems. I'm now going to substitute in the two factors that I have for my b. So now I'm going to rewrite my problem as negative 6a squared, subtract 10a, subtract 15a, subtract 25. I'll highlight again so you can see that these were the same and these are being substituted in, okay? So this is what I've got. Let's see if you can see here. Yeah. All right. Again, negative 25a is my b, right, in my equation. The factors I have are negative 10 and negative 15. Is negative 10a subtract 15a equivalent to negative 25a? Yes. So I'm rewriting this correctly, just wanted to show you. Once I substitute in, my next step is to do grouping. Well, 6 and 10 both are even, 2 and a's, right? 15 and 25 again. So I'm just going to go ahead and group them as is. So negative 6a squared, negative 10a, negative 15a, and negative 25. Now they are grouped. I substituted and now they're grouped. My final step is, well, almost final, GCF. Find the greatest common factor of each. Okay? All right. So sorry, I know I'm like moving these papers along. I'm trying to get it even there. Whoop. All right. So again, what we did was we substituted out for our b the two factors we got, and now we grouped. Now we're doing our GCF. What's the largest number that can be divided into both negative 6 and negative 10? Negative 2. I'm taking a negative 2. And 6 has an a squared and 10 has an a, or negative 10 has an a. So I could also take out an a. Now if I divide negative 6a squared by negative 2a, I get positive 3a. And if I divide negative 10a by negative 2a, I get positive 5. So far, that's what we got. Now I'm going to go ahead and look over here. What number and variable, if one, can I divide into both negative 15 and negative 25? Again, the greatest common factor would be negative 5. Only the 15 has an a, negative 25 does not, so I can't pull out an a. So negative 15a divided by negative 5 is positive 3a. Negative 25 divided by negative 5 is positive 5. All right, so now I want to look, and I want to make sure, is what's inside my parentheses the same here and here? Yes, so it's a good indication I'm doing something right. So I'm going to bring down the term 3a plus 5. That's one of my factors, and the other one is negative 2a subtract 5. Because whatever my greatest common factors were that I pulled out becomes my other factor. So my answer then is 3a plus 5 and negative 2a subtract 5. There it is. Ish. Sort of. Weep. Okay? So we're doing okay? All right. So there was two equations that we just did. And let's see if we can do one more real quick. Next equation, 6n squared plus 5n subtract 6. I went ahead and did the beginning work of multiplying 6 and negative 6, getting negative 36, and went ahead and got my factors. And I know that the two factors that are going to work are negative 4 and 9, because negative 4 plus 9 is 5. So now working our new steps, I'm going to substitute in the negative 4 and the 9 for the 5n. So now my equation is going to be written as 6n squared minus 4n plus 9n subtract 6, because I substituted in, right? Because negative 4n plus 9n makes 5n. I'm just kind of working backwards. Now I'm going to group the 6n squared and the 4n and the 9n and the 6. Substitute, group, now greatest common factor. What can be the greatest number and variable that can be divided into both 6n squared and 4n would be 2n, and what I end up with is 3n subtract 2. What can be divided into both 9n and negative 6 would be a 3, and I end up with 3n subtract 2. Again, what's inside my parentheses is the same, so my answer would be 2n plus 3 and 3n minus 2. 2n plus 3 and then the 3n subtract 2.